Good morning, students. Is it audible to you? My voice is clear, everyone? Boys, is it clear? So, right. So, yesterday we are discussing that what is called atomic spectrum, hydrogen atom spectrum. We are discussing, right? Lyman series, Balmer series, etc. There is 5 series spectral lines are there, right? So, look carefully. Yeah. So the series spectral line series we discussed, that is different spectral line series we have. So just I will say once again. So continuation to yesterday. N equal to 1, 2, 3, 4, 5, 6, so on infinity. So already we discussed some energy of n equal to 1, 13, minus 13.6, minus 3.51, 1.51, 0.84, like that we discussed yesterday, right? So in Lyman series basically start N1 will be start from what is energy equation or emission of energy or lambda wavelength emitted. Basically wavelength is 1 by lambda, that is wave number, is equal to R into Z square, but hydrogen atom Z is 1 only, 1 upon N1 square minus 1 upon N2 square, correct? So for Lyman series N1 is 1 and N2 will be 2, 3, 4 and so on. That means electron is comes from any higher energy levels or any excited state to ground state. Any excited state to ground state that lies under Lyman series, and I told it will lies in UV spectrum or ultraviolet region, it will lies. So this is basically like this. Second, Balmer series. So any electron jump from higher excited state to first excited state. Any electron jump from higher excited state to second state. That means it starts from third to second, fourth to second, like that. So that is this. Third to second, and fourth to second, fifth to second, etc. And next, passion series, which will like this, so on. And thereafter, bracket series. And finally, P fund series. Like these many series we have. Okay. So in this series, basically, this Lyman series. Okay. So, but Lyman series first spectral line, Lyman series first spectral line, which is coming first excited state to ground state, which we call it as K alpha. K alpha. Okay. And this is K beta. And this is K gamma. Right? K, L, M, N shell we have na. K, L, M, N shell. First state, first orbit or first shell we call it as K shell. Second shell is called M L, K, L, M, N shell we have, right? So that based on that, because Lyman series all are coming from higher energy state to ground state is coming. So first one spectral line we call named as coming from 2 to 1 called K alpha, 3 to 1 K beta, 4 to 1 K gamma line we call. K alpha, K beta, K gamma and so on. These are the spectral lines for Lyman series. So sometime in question what they will give, instead of the giving energy levels from 4 to 1 or 3 to 1, they will give K alpha or K beta or K gamma. Right? So what is the wavelength emitted by K beta if they ask? If electron jump and it is form a spectral line of K beta, what is the wavelength emitted by photon? So K beta means what? N equal to 3 to N equal to 1. Basically K means it is a transition coming from higher to 1. Clear? Lyman series. K means Lyman series. Clear? Now similarly for second shell, basically K, L, M N shell, right? K, L alpha, L beta, L gamma like this. M alpha, M beta and M gamma and so on like this shells. Clear? So don't confuse if the question they given in terms of alpha, beta, gamma or K alpha, K beta or something, or M alpha, M beta, M gamma they given. So remember K shell, first shell it is, so it will come to ground state. So that is Lyman series, right? So higher to lower, alpha means second to 1, beta means third to 1, gamma means fourth to 1. Similarly for L shell, L alpha, L means second, so second it is transition to higher to lower, that is lower means second only for L. So L alpha, L beta, L gamma, M alpha, M beta, M gamma like that. Clear? So these are the spectral lines in terms of alpha, beta, gamma. So this note down it. Is it clear? That alpha, beta, gamma is clear, right? Right. So when it is Lyman series, Balmer series, Paschen bracket, P-Fund series, so yesterday I said how to calculate maximum and minimum wavelength emitted by the photons when it is coming from higher to lower energy state. Correct? Very good. Now look carefully. So yesterday only I discussed N1 is equal to N and N2 is equal to infinity. N1 is equal to N, N2 is equal to infinity. So this quantity become N 1 by N1 square minus 1 by N2 square become, what happened? Maximum value it will come. Maximum value will come. So this quantity maximum means 1 by lambda will be minimum. So lambda is equal to minimum will come. So N1 is equal to N, N2 is equal to infinity. So that lambda minimum, for minimum it is. For minimum. So 1 by lambda minimum, yesterday only derived, but still I am just revising that. 1 upon N1 square, that is N square only, 1 by infinity square, nothing but 1 by infinity is 0. So finally, implies directly I can write lambda minimum becomes R by N square will come, 1 by lambda is equal to, the lambda minimum is N square by R. For any series you take, for any series, the minimum wavelength emitted by that series will be N square by R. What is N? What is N means? Lyman series, higher energy to ground state. Means for Lyman series, N is 1. For Balmer series, N is 2. Paschen series, N is 3. Like that. From which energy state the electron is transition from higher to that Lyman series or Balmer series or whatever it. So from which energy state to which energy state is coming in particular series. Lyman means first ground state, Balmer means second or first excited state, Paschen means second excited state, like that. The N value decided by like that. Then this is for lambda minimum. Okay. The next lambda maximum. What is lambda maximum means? So as the electron make transition from higher, so lambda maximum will be, this is you see. For Lyman series you take, it is infinity to ground state, minimum will come. Then immediate second to 1, it's the maximum emission of energy or maximum wavelength it will come. Right? So look carefully here. Lambda maximum. For maximum, for max, so we can write N1 is equal to N and N2 become immediate 1. Immediate 1. That is for Lyman series, N1, N is 1. N2 become 2 only. For Balmer series, N1 is 2. N2 is immediate 1. N plus 1. That is 3. Right? Like that. So N1 is equal to N. N2 is equal to N plus 1. So again we can write for lambda maximum, that is equal to R into 1 by N1 square, that is N square minus 1 upon N plus 1 whole square. Clear? So just yesterday we derived this one, or 1 by lambda max, it will come 1 upon R. So here it will come LCM N square into N plus 1 whole square. And here N square plus 2N plus 1, A plus B whole square modulo expand, and minus this LCM is minus N square. Correct? So from here, directly I can write minus N square plus N square cancel. So lambda maximum directly I'm writing because already yesterday we derived, right? So this is N square into N plus 1 whole square by 2N plus 1 is there. 2N plus 1 into R. Clear? 2N plus 1 into R. So lambda minimum N square by R, lambda maximum N square into N plus 1 whole square by 2N plus 1 into R. Clear? Is it clear? Now something, if the Lyman series, Balmer series, Paschen series, if they ask what is the ratio of lambda maximum to lambda minimum or lambda minimum to lambda maximum, anything, ratio for any series. So ratio of lambda max and lambda minimum, you see ratio, lambda max by lambda minimum we are doing. If they ask reverse, we can do it according to the question. But generally lambda max by lambda minimum I'm doing. So this by that simply. So that means N square into N plus 1 whole square by 2N plus 1 into R. This is lambda maximum. And divided by lambda minimum, that is N square by R. So N square by R. N square by R. That means R by N square it will come. Correct? So R cancelled out. N square cancelled out. So finally, the ratio of lambda max to lambda minimum, will it come? N plus 1 whole square is left, denominator 2N plus 1 is left. So directly N plus 1 whole square by 2N plus 1. This is the ratio of maximum to minimum wavelength of any spectral series. Any spectral series. For numerical question, directly we can substitute the values and we'll get it. Clear? So what I said, it is clear now. Lambda maximum, lambda minimum is clear for every series. How to calculate lambda minimum, lambda maximum? Yes or no? Everybody clear? And this K alpha, K beta, K gamma, L alpha, L beta, L gamma, is it clear? What is the meaning of L alpha, L beta? It is a simple. L means LCL. LCL means second. So Balmer series. First line, second line, third line, etc. M shell, third means passion series. So alpha, beta, gamma means first line, second line, third line, like that. Okay, up to alpha, beta, gamma, remember enough. That is mostly they will ask that much only. Okay, so is the point is clear? Alpha, beta, gamma in spectral lines of hydrogen spectrum series, and what is maximum wavelength of that particular series and minimum wavelength of particular series, and the ratio finally. Is it clear, everyone? Student, is it clear, everyone? Any doubt? Note down first. Right. One question we'll do based on this one example. The ratio of maximum and minimum wavelength of Balmer series of H atom. In Balmer series of H atom, what is maximum and minimum wavelength ratio we need to calculate? What is the maximum and minimum wavelength we need to calculate? So you can use directly this formula, okay? Or we can use lambda minimum, lambda maximum, we'll calculate and divide whatever it is. So let us see. First, normally we'll do directly. We can do in examination directly that formula we can use it. But let us redo this first. Lambda minimum. Tell me, Balmer series. They said Balmer series means started with L shell. That means 2 n equal to 2. So that is n equal to 2. Correct? Then lambda minimum. Lambda minimum value is what? N square by R. That is 4 by R. Yes. Similarly, lambda maximum. N square into n plus 1 whole square by 2n plus 1 into R. Right? So this can be written as n square is 2 square, 2 plus 1, 3 square by 2n plus 1, 2 into 2. Can I write 2 into 2 directly? Can I write 2 to the 4 plus 1, 5. N is equal to 2. I am substituted in that. That's it. So finally, this is become how much? 2 square, 4 into 3 square, 9 by 5 into R, 36 by 5 R. This is lambda maximum. This is lambda minimum. You see 4 by R, 36 by 5 R. 36 by 5 R means something 7.2. by r. This is 4 by r. So lambda maximum only, numerically also, correct? So now ratio they want to find lambda max to lambda minimum. So ratio is what? 36 by r, pi r into 4 by r. So r by 4. So r cancel out, 4 ones are 4 nines are. So ratio will be 9 by 5. 9 by 5. Directly from using this formula also we'll get it. So n is how much? 2. 2 plus 1. 3. 3 square 9. 2n plus 1. 2n plus 1. 5. So 9 by 5 direct answer. But we need to just simply calculated lambda minimum, lambda maximum, how we use the formula. That's it. Otherwise, if they ask only ratio, direct formula, we can use this one. Direct 9 by 5 will get. Okay. Sometimes they will ask what is lambda maximum and what is the ratio of lambda maximum to lambda minimum, they will ask. So at that time, both the formulas we have to use. Question is clear? Sometimes if you don't know, if you not remember what is lambda maximum, lambda minimum value formula, not remember, what we have to do? Basic concept only, 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. But lambda maximum means n1 should be n, n2 will be n plus 1 immediately. Lambda minimum means n1 is n, n2 will be infinity. That's it. That basic you remember. If you formula not, if you remember, it is good. If not remember also, some confusion is there. 2n plus 1 or 2n minus 1 is there. Confusion is there, means basic formula we have to use to avoid confusion. If direct formula remember, it's good. Clear? So one more question you see. Find the wavelength of photon of L beta of H atom. Why I am writing H atom means that something they will given lithium or helium they given, that Z square also take into consideration, right? L beta of H atom. So we know that. And helium plus they given means what you have to take? Atomic number, that Z square also there. So Z square also take into consideration. So Z square will be 2 for helium, right? Like that. Find wavelength of photon of L beta of H atom. Wavelength of L beta. See, they given basically they don't want to calculate lambda maximum and lambda minimum. They want to calculate only L beta wavelength how much. So basically for this we required what is L beta actually. What is L beta? L beta is a such kind of transition of electron. L means second shell, correct? So beta means second line in that second shell. That means Balmer series. Second shell means Balmer series. In that beta, alpha means first line, beta means second line. That's kind of it is, beta will be n equal to, this should be n equal to 2 only because L shell. Second line it is coming, that is n equal to 4 to 2 is coming. This is right, L beta. L alpha means 3 to 2, but L beta means from higher to that, 4 to 2. So how I represent, how I got n equal to n1 is 2, n2 is 2, 4, how I got means they given L beta. L means Balmer series. So Balmer series start at the second level only, or second, first excited state or second energy level. Then beta means second line. Second line in Balmer series from 4 to 2 only. Correct? So beta wavelength how to calculate now? Directly 1 upon lambda is equal to R into 1 by N1, N1 square, 1 by N2 square. This is formula, right? So 1 upon lambda is equal to R, value will substitute later, 1 by N1. N1 is what? 2. 2 square minus 1 by n2. n2 will be 4. 4 square. Clear? So this is implies we can write here 1 by lambda is equal to r into 1 by 4 minus 1 by 16. LCM how much? 4 ones are 4 fours, the 16 LCM, right? 16 here, 4 minus 1, 3 by 16, that is 1 by lambda. Yes or no? So 1 by lambda is equal to 3r by 16. Then lambda is equal to what? 16 by 3r. 16 by 3r. R value we know 1.1 into 10 to the power of 7 meter, I said. R value 1.1 into 10 to the power of 7 meter. Sometimes in examination they will give in terms of R only, in meter they will give. Okay, meters. In terms same like 16 by 3 or meter they will give options. Otherwise, if they're not given in meter, so sometimes angstrom they given, what we have to do 16 by 3, R value is 1.1 into 10 to the power of 7. So this is become 16 into 10 to the power of minus 7 by 3.3. Right? So 16 by 3.3, how much value? 5 point something will come. Tell me 16 by 3.3. 4.848. 4.848 it is coming. Shall I write there? Or I will write here. 4.48488. So lambda is coming 4.848 into 10 power minus 7 meters. So if I multiply 10 to the power of plus 3 and 10 to the power of 10 to the power of 3 and multiply divide, what happens? 4.848 into 10 to the power of minus 7, 10 to the power of 3 multiplying 3 dividing. So this will go 10 to the power minus 3 mean 10 power minus 10 and 10 power 3 multiply here. This is 4848 into 10 power minus 10 meters. Then 4848 angstrom it is. Clear? So if they ask in angstrom, so we need to convert like this. If they ask in meter, directly here itself we can stop meters. Or in sometimes in they will give in option R only. Here itself the answer it will come. 16 by 3 R in meters. The question is clear how to calculate. Student, is that question is clear? Anybody? Any doubt? First of all, what is L beta is clear, and the formula is normal only. Once you get what is L beta, then only will get what is N1 value, what is N2 value. Clear? Like that. Any doubt you ask me? Otherwise, you no doubt. Why N1 is equal to 4 and N2 is equal to 5? L beta. K, L, M and shell, right? So L means second only, that is 4 to 2. So next question you see similar to that. So this is way how to calculate the frequency, sorry, wavelength. So we'll see one more question for frequency. Write down the question. Find the frequency of photon emitted by electron when it is jump from fourth excited state to second excited state. Find frequency of photon emitted by electron when it is jump from fourth excited to second excited state. It is here. Find frequency of photon emitted by electron when it is jump from fourth excited state to second excited state. So simply frequency we need to calculate, right? Yes, we can calculate the frequency, but before that, find frequency fourth excited state. Fourth excited state means what? Fourth excited state means fifth energy level, because ground state is n equal to 1. First excited state is the second. So like that, fourth excited state means what? Fifth energy level. So n is equal to 5. Second excited state means n equal to 3. Correct? So it is making a transition of fourth excited state, nothing but n equal to 5, and second excited state, nothing but n equal to 3, right? So now it is making a transition of electron from here to here. Then there will be a photon will be generated, which is h nu amount of energy will release. So what is the frequency they are asking? This is a question actually, right? So here clearly can I take n1 is 3, n2 is 5. Then frequency they want to calculate. So frequency means how to calculate? 1 by lambda formula we know, right? 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. So 1 by lambda is equal to r, but frequency they want to calculate. We know that photon travel with the speed of light. Photon travel with the speed of light. Then frequency can be written as frequency into wavelength, speed of light, that is c. Then frequency is equal to c by lambda. Yes or no? C by lambda. So 1 by lambda is there already. So if you multiply both the side with the c, so I will get what is frequency. C by lambda, that is f is equal to c into r. 1 by n1 square, n1 is 3 square, 1 by n2 square, 5 whole square. Now we will substitute the values. C 3 into 10 to the power of 8, R 1.1 into 10 to the power of 7, 1 by 9 minus 1 by 25. Simple? Yes. So now we need to calculate. So this is 3.3 into 10 to the power of 15. So LCM is how much? 9 into 25 only. So 25 minus 9. So 25 into 9 will be 225. Correct? So 25 minus 9, it will be 16. Correct? So it will be how much it will come? 3.3 into 10 to the power 15 into 16 by 225. Okay? So if you cancel how much it will come, you just calculate it. So which is 3.3 into 16 by 225, right? So 3.3 into 16 divided by 225. So 0.2346. 0.2346 into 10 to the power of 15. Or finally we can write the frequency can be written as, so it is 23.46 into 10 to the power 13 hertz. Frequency in hertz it is. Is it clear? The question is clear? Clear that question? Once you see any doubt, you ask me. Whatever, 0.21, 0.23 into 10 to the power of 15 or nearly 0.23.46 into 10 to the power of 13. That's correct only. So is it clear that question you understood? See, no need to remember again formula for frequency. Just remember the formula of lambda. 1 by lambda automatically multiply with C, we can get it. Because if you remember the formulas, so many formulas will come. So 1. So this way. First of all, is everybody clear what is second excited state, fourth excited state clear na? Ground state means n equal to 1. First excited state means n equal to 2. Second excited will be 3. Third will be 4. Fourth will be 5. Like that. 5 to 3. So like this. So we know how to calculate frequency by different energy state given. Yes. And how to calculate wavelength also. Just now we calculated. And we know how to calculate maximum and minimum wavelength of any spectral series. Clear? So let us, now we will discuss. So is it clear with question before I'm going to next topic? Look here. Look here. See, number of emission lines or emission spectral lines we call. Emission spectral lines. See how many number of spectral line, emission spectral lines will come when possibility, when electron jump from one energy level to other energy level. Look carefully, let us see. Look. 1 second. All right. So this is n equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5, n equal to 6 energy states, energy levels. So let us consider. So electron make transition, absorption spectrum. I said, what is absorption spectrum? Whenever you supply energy, so electron will absorb that particular energies and it will jump to higher energy state or excited to higher energy state. So during that, whatever the energy we supplied or what amount of energy is absorbed, what amount of photon energy is absorbed, that absorption spectrum we call. Correct? So during by absorbing the energy by electron, let us say it is jump from, let's consider it is, okay. It is went to first to 5, it is gone. Electron jump from year to year. Okay. Directly N1 to N5 it is jump. But I said when electron is excited to higher energy level, so it won't be stay for longer duration time at excited state. So because it want to attain the equilibrium or stability, or it want to attain its stability, so for that stability, that minimum potential energy should be present. So because stable or stability means what? Minimum potential energy should be present. So that is present minimum potential energy on the ground state only. So that's the reason immediately the electron want to, which is excited to higher energy levels. So immediately less than 10 to the power of minus 8 seconds, less than 10 to the power of minus 8 seconds, it will come back to ground state. So while it is coming back to ground state only, it will emit the radiation in the form of photons, electromagnetic radiation. That energy we know how to calculate, and frequency we know, wavelength we know. Then what I mean to say here, so electron is excited from ground to fourth excited state, nothing but fifth energy level. It is excited to this. So it won't stay for long duration of time. Immediately it will come back. So while it is coming back, how many spectral lines possibility? The number of spectral lines emitted by this electron, we need to calculate. Number of spectral line emitted by this electron, we need to calculate. Possibility, how many number of spectral line emitted possibility is there? That we need to calculate. Tell me yourself first, how many spectral lines it can be emitted? Because directly it is gone from energy level 1 to 5. Only one absorption spectral line is there. Only one absorption. So this much of energy absorbed, which is equal to move from N1 to N5, and it is jump from N1 to N5. Now while it is written back, while it is coming back from fifth to 1, what are the possible energy level or spectral lines? What are the possible spectral lines it can be emit? Tell me number of spectral lines. Only one, because n equal to 5 is when, and coming back to 1 only directly. Only one or more than one? Answer it. Only one or more than one? Is it clear? First of all, the question or the concept, what I'm trying to explain, is it clear? Normally, when we supply energy like ionization energy, please supply, or the more than ionization energy supply, what will happen? It will absorb energy, electron will absorb energy and jump from lower energy level to higher energy level, or ground state to excited state. So that means excitation of electron. So that is, electron is excited from ground state to fourth excited state. So I shown in the diagram. But it won't stay for long time in the excited state. So again, it will return back to the ground state immediately. While it is written back during emission, I'm saying, how many possible emission spectral lines it can be emit? The number of emission spectral line during it is coming from 5 to 1. That I want to calculate. Tell me. tell me, is equal to 1 only? Because it may come directly from 5 to 1, right? Directly 5 to 1 it is come. So only one spectral line or one photon only of wavelength it emit, or many photons of different wavelength it emit. Possibility I am saying. One or more than one. Think and tell me. Girls, answer it. One or more than one spectral lines will come. So what will be the answer? So the answer is definitely more than one. Why it is more than one means, see, possibility I am asking, possibility I am asking. It can come after excited the electron to fifth energy level. It may come directly from fifth energy level to first energy level, first possibility, and it can come from fifth to fourth also, and fifth to second also, fifth to third also. Possibility I am saying fifth to fourth also. Next possibility is what? When electron is comes to this state, it when it is come to this state in this category, you see. So in 5 to 4 it came. 5 to 4 it came. But electron always trying to attain its stable or stability. So it is just tried when electron is jumped from 5 to 4. So when it is come to 4, no stability is there. So immediately it want to jump from lower energy level again. So that means there is may possibilities there between n to 4 and 3 also. 4 and 3 also. And 4 and 2 also. And 4 and 1 also. That means depends upon that. It can jump directly to the ground state or different via it will go for 5, 4, 3 also. Right? Next possibility is what? 4 to 3 to 1 gone. Right? So 3 to 2 also come. 3 to 1 also come. Then 2 to 1 also will come. So these many spectral lines possibility is there. These many spectral line possibility is there. So how can we count like this means how many it can be count means. So generally it can be counted as, that is a formula is there. What is that formula? Let us see. Look here. The formula is see, for example, generalizing I am saying. Electron make a transition of N1 is equal to N1 and this is N2. That N1, N2 can be anything. Maybe it is excited from fifth to 1 or fifth to third or 4 to 2, anything. N1 can be any lower energy level and N2 can be any higher energy level. So condition is N2 should be greater than N1. An electron is present in higher energy level and jump into lower energy level. Then it is coming into this. How many? So spectral lines will emit. So number of emission lines or spectral lines. Possibility I am saying when it is electron jump from N2 energy level to N1 energy level. N2 is greater energy level, N1 is smaller energy level. So it can be N1 can be a ground state or N1 can be any other state also. It's not compulsory that it should be a ground state. Right? So in general I am saying, so the number of emission lines will be N. Number of emission lines. Number of emission lines. Possibility, that is n, which is exactly equal to n is equal to n2 minus n1 plus 1 into n2 minus n1 by 2. n2 minus n1 plus 1 into n2 minus n1 by 2. n2 minus n1 plus 1 by n2 minus n1 by 2. Clear? Suppose if n1 is suppose it is the ground state only. n1 is ground state only directly. n1 is ground state if it is. If n1 is ground state 1 and n2 is any higher energy state. That means any higher energy level to ground state is transition or jumping from higher to ground state. If that case, then the number of spectral emission lines will be directly, you substitute n1 is equal to 1, n2 is n here. n1 is equal to 1, if you substitute minus 1 plus 1 cancel out here. Correct? Here n2 means n1. n2 is n only, n minus 1. Here n2 is n, this is cancel out. So n into n minus 1 by 2 it will come. Are you getting? I once again explain, you see. n1 is 1, n2 is n. That means electron is jumping from higher energy level to ground state only, directly ground state. For that, this is a formula, direct formula. If electron jump from higher to any other lower energy level, not the that ground state, that means this you can use. So that means n1 is 1, n2 is n. If you take n2 n, otherwise substitute n2 n minus n1 is 1 plus 1 into n2 minus n1, that is n minus 1 by 2. So n minus 1 plus 1 cancel out. So directly n into n minus 1. So this is n into n minus 1 by 2. These many number of lines will be emitted. Possibility is there. Is it clear? Yes or no? So according to our assumption list, so it is jumping from n equal to 5 to n equal to 1. Na? So directly ground state only coming. So n equal to 5 you substitute here. 5 into 5 minus 1. 5 into 5 minus 1. So 5 into 5 minus 1, 4. 5 4 is 20 by 2. 10 will come. So I have gone 10 will be, you can count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 spectral lines are possible. So like this, 5 into 5 minus 1, 5 into 4 by 2, 10, 20 by 2, 10. If it is not ground state, so that formula we have to use. If lower one is not ground state, for example, n equal to 5 to n equal to 3 only. Electron jump from n equal to 5 to n equal to 3. So what are the possible number of emission lines will be me? So there n2 will be 5, n1 will be 3, you need to substitute. Clear? Important point only it is. The concept of number of emission spectral lines when it is emitted by excited from higher to lower energy level is clear. One is for this, other one is that. For ground state means directly n into n minus 1 by 2. n into n minus 1 by 2. Have you got how we draw possibility? This is a possible spectral lines, it can be emit. Clear, na? What happened, girls? You are not responding. Is it clear? Yes or no? So note down that formula. So this is moving from ground state to fourth excited state, then possibility these may number of spectral lines. Clear? Now look carefully. So whenever electron is jump from lower to higher energy state and it come back to higher to lower immediately because of to attain stability. So while it is coming from higher energy level to lower energy level, so because of it is jump, right? So when it is jump from that, so there will be a little bit of recoil of atom will be takes place. Recoil of atom means what? Basic, like you have studied in first year. When you fire a gun, then bullet is fired from a gun. Bullet will move forward direction and gun will recoil. That means recoil means it slightly jerk in backward direction. That is called recoil. Recoil of gun, right? Similarly, when we jump out from a boat, when we jump out of a boat, so when we jump in forward direction, then boat will go backward direction. Action reaction pair it is, right? So like that. So recoil of atom. Recoil of atom. What is meaning of recoil of atom mean? Whenever an electron is jumped from high energy level to lower energy level, during this jumping, there is a slight change or there is a recoil energy or recoil of atom. Means like gun is moving backward direction, right? In gun and bullet system. Very similar to that, when electron is jumped, there is a slight changes or energy, recoil energy will come from atom. So how it can calculate recoil energy of atom or recoil of atom, we'll discuss. Recoiling of atom. Electron when jump, when electron jump from excited state to lower state or lower energy, lower state. That may be a ground state or any another excited state. So the recoil energy of atom is what? Recoil energy of atom. What is recoil energy of atom means? See, simply electron inside the atom only. So electron is jumped. So whatever the force is applied, when it is jumped, it will release a photon, right? Photon will exert some force, right? So when it is jumped, the action reaction forces are same only, imbalance, the balancing force only are internal forces only. That means momentum will be conserved. So initially stationary, electron is stationary. When it is jumped from higher energy level to lower energy level, so when it is jumping, it will have some velocity. Or that means electron also have momentum, or overall atom will have some momentum, and photon also have momentum. So due to this, two are there. One is after it is jumping from higher to lower, it will release a photon. Photon has an energy h nu, it has a momentum h by lambda, we know it. So that means the jumped or released photon has momentum. So from where it is got, it means because of jumping of electron. So momentum of photon is h by lambda means inversely the atom momentum also should be h by lambda only. Like it is very similar to, you can imagine gun is backward direction with momentum and forward direction the bullet is moving. In that case, bullet momentum is equal to gun momentum, right? So initially rest, finally both are moving, mean total momentum initial is equal to total momentum final. But initially rest is there, initial momentum 0, but finally both are moving, so sum of those momentum should be 0. So very similar to this, initially atom and electron is rest only, but when electron is jump from higher to lower, photon is released and photon is having momentum of h by lambda. But initial momentum of overall atom is 0, so final should be also 0, right? So for that, to balance it, electron is jump from higher to lower, it releases a photon of momentum h by lambda. So in opposite direction of that, atom should have same momentum of h by lambda, right? So during this, the momentum of atom is equal to momentum of photon. So can you write the momentum of atom is equal to momentum of photon? So we can write momentum of atom. So directly P is equal to momentum of photon is h by lambda. Correct? Then we need to calculate the recoil energy of atom. So when we have a momentum, can we find out energy? Recoil means motion. Moving means energy. Which energy? Kinetic energy. Right? So recoiling energy means what? Kinetic energy only, right? But it is recoiling or moving in backward direction. That's the reason recoil energy we call. But indirectly it's a kinetic energy only. So implies recoil energy is equal to, we know kinetic energy P square by 2m, correct? M is mass of atom. So P square by 2m. So P is h by lambda. Yes or no? So that means h square by 2m lambda square. Recoil energy E, or you can take recoil energy, or you can write ER, that is recoil energy, h square by 2m lambda square. Lambda is what? C by F. F is equal to, or lambda is equal to C by F. C by F. So C by F means C square F square, it will come. Frequency. Because C is equal to F lambda, right? Based on that I have written. So h square F square by 2m into C square. H square F square by 2 mc square. So h is a Planck constant, F is a frequency of photon released during that jumping, C is the speed of light, m is the mass of atom. Here lambda is the wavelength of photon emitted. So this is recoil energy, remember. Sometimes they ask, so directly we can do it. So m is what? Mass of atom. Lambda and frequency are of photon it is. Because photon only releasing, photon, lambda and wavelength, frequency of that. So recoiling of atom is clear, and energy how to calculate is clear. Student. MC square E means again that is different energy, MC square again. Then again if you write here E and here E, you will confuse. So don't write that. H square F square to MC square. Okay. That is MC square energy, different mass energy, equivalent energy there, and here recoil energy it is. So this is called recoil energy. Yes, that is Einstein relation only, but you cannot write here. Is it clear? This is recoil energy of an atom. Simple only, simple concept of momentum conservation only. Momentum of photon is equal to the momentum of recoil atom. That's it. Then once you get the momentum, P square by 2m, it's the energy. Simple concept. Momentum of recoil atom is equal to momentum of photon because photon is releasing. So photon momentum we know h by lambda. So energy is what? Whenever I have a momentum, it has a kinetic energy. P square by 2m is the energy, right? Recoil energy it is. So if you don't remember the formula also, directly recoil means so momentum conservation. So recoil of atom means energy photon is releasing. So in that way you need to recollect the concept. Are you getting my point? If you not remember, because formula we cannot remember. Like 1-2 days we can remember. After that we cannot remember. But the concept of recoil, if they come, recoil means what? Momentum will be same. Momentum of atom and momentum of photon should be same. So based on that, you need to relate the equation. Correct? Now look here, some basic things here. Look. So we have calculated radius. Radius or nth orbit radius we got 0.53 z square by n square by z angstrom, right? Do you remember? Yes. Then velocity in nth orbit is 2 into 10 to the power of 6 nearly into z by n meter per second. Z by n meter per second. Now acceleration. Acceleration in nth orbit. Acceleration of nth orbit is what? V square by r. V square by r, centripetal acceleration of electron. V square by r. So V square this much, correct? And r this is. So can I write this one? So directly I am writing this is nearly V square 2 into 10 to the power 6 whole square, and I will write this is into 10 to the power minus 10 instead of writing angstrom. So whole square into z square by n square by r. R means 0.53. 1 upon 0.53 into 10 to the power of minus 10 into n square by z is there. So n square by z means n square denominator, z in the numerator. Correct? So if you cancel out something, 10 power minus plus 12, this is minus 10, it is coming 4 it is. So nearly it is an acceleration of electron in nth orbit will be 2 to the 4 by 0.5 nearly take. 4 by 0.5 means 2. So 2 into 10 to the power of 12 and this come up means 22. So nearly z's power cube by n power 4. Or directly we can write an directly proportional to z cube by n power 4. Clear? This already in the beginning last class we have discussed. By using this, some other points I need to discuss here. What is that? Look here. Acceleration, velocity, radius we got. Next, what we can calculate? Time period. Time period T. Time period is what? 2 pi by 2 pi in circumference. One circumference of orbit is how much? 2 pi r. By distance by speed, right? Time is equal to distance by speed. 2 pi r by r small r I write. 2 pi r by v. So r and v we know. R and v we know. Again directly r by v. So I will substitute r 2 pi into r is 0.53 into 10 to the power of minus 10 into r is n square by z. by V value 2 into 10 to the power of 6 into what is that? Z by N. Z by N will go up. Correct. So again it will be something cancel out and T is directly proportional to what it will come, you see. N square into N. N cube by Z into Z. Z square. Remember this. This is a time period. Correct. Then omega, angular velocity. Angular velocity. Angular velocity is what? Angular velocity is omega. So omega is 2 pi by t. Total circumference 2 pi radians by time period t. So this is proportional to what? Inversely proportional to t, right? That is z square by n cube. Z square by n cube. Angular velocity. Next, frequency. F. So frequency F is 2 pi or 1 by t. Frequency also 1 by t only. So this is also proportional to z square by n cube. Correct? This is frequency. Angular frequency. Next. So once you get a frequency, current, orbital current or current produced by revolving electron, current I. I basically what? Charge by time, right? Charge by time. Charge by time. So charge, nothing but Q by time. So in circular orbit, one time period we have to take. Time period T. So for electron it is we are writing. So E into 1 by T. 1 by T means again Z square. So proportionality I can write it is directly proportionally I am writing. Proportional become 1 by T only again. Z square by N cube. Or this can be written as Q into F also because 1 by T is frequency. Clear? Next. Current we got, right? The electron is revolving in a circular orbit, it's producing a current. So current carrying circular orbit, nothing but current carrying coil produce a magnetic moment or it has magnetic field at center. So what is magnetic moment? Magnetic moment, that is M bar. Magnetic moment is what basically? I into A, right? I into area, that is pi r square. So I is proportional to Z square by N cube and R is proportional to Z square by N square by Z. So can I write directly proportionality I am writing. So I is proportional to Z square by N cube and R is proportional to N square by Z. Nothing but N square, that is N to the power 4 by Z square. Z square cancel out, N power 3, N power 4 cancel out. So finally the magnetic moment is directly proportional to N only. N only. N is a principal quantum number, right? N. Then finally magnetic field. Magnetic field, that is B bar. What is magnetic field? Mu naught I by 2 r at center of the circle. So mu naught I by 2 r. So it's a proportionality. I is proportional to same Z square by N cube and R is proportional to this. So I can write here. Directly I am writing here. I is Z square by N cube. R is N square by, that is Z square by N cube into N square by, so reverse it is come, right? Because R in denominator. Z by N square. So it is proportional to Z cube by N power 5. Clear? So these are some related proportionality for nth orbit. Why I said this, all the things mean, sometime they will ask, what is magnetic moment of revolving electron in second orbit? Ratio of second orbit to third orbit they will ask. So ratio means that you have to say. Or second orbit of the magnetic moment of revolving electron in second orbit of hydrogen atom to the helium. Second orbit of helium they will ask. So there Z and N required. So ratio, whenever they ask ratio, so this is suitable. But in this one, you mainly remember this. R and V remember. R and V. If you remember R and V, remaining you can calculate yourself, because no need to remember all these things. Right? I know that what is R and V independent. The remaining I calculate according to the formulas only. Right? So remember only Rn, N square by Z, Vn, Z by N. Correct? N square by Z and Z by N. So once N square by Z and Z by N we know, then remaining acceleration V square by R, time period 2 pi R by V, like this. So then automatically everything will come. Is it clear? Yes or no? You note down that. Any doubt you ask me. Now is it clear my voice? Student, both boys and girls, is it clear what I written on the board? Just simple proportionality only. But how it is came that you remember, because it's not to remember all these things is not possible, but still you can remember Rn and Vn. The remaining you can calculate yourself. Rn and Vn. That is N square by Z and Z by N. The remaining you can calculate yourself, but only the thing you know, what is magnetic moment? I into K. What is magnetic field at center? Mu naught I by 2R. What is angular velocity? 2 pi by T. Time period 2 pi R by V. General definition they are all. Clear? Note down. So is it clear? So this is about atoms. About atoms. So this is atom chapter completed. So what are the things we have discussed in the atom? First is different types of atomic model. Right? In that Rutherford atomic model and that alpha particle scattering experiment, in the two things important. One is number of alpha particles scattering at different angle theta. That is, n is inversely proportional to sine to the power 4 theta by 2. Theta is angle of scattering. One equation there. And one more is closest approach distance in alpha particle scattering experiment. Closest approach distance that you can calculate by using the concept of kinetic energy of alpha particle equal to the potential energy of the system, or potential energy between alpha and nucleus. By using that concept, we can calculate closest distance. Once you calculate closest distance approach, then impact parameter. Impact parameter is closest distance approach by 2 into cot theta by 2, where theta is angle of scattering. Correct? Then after that, we are moving into Bohr model. Bohr model, three postulate we know, that is every electron revolves around a circular orbit in which it is not radiate energy because it is stable orbits or stationary orbits we call, right? Such type of stationary orbit are defined as second postulate, that is in which angular momentum is conserved. That is mvr is equal to nh by 2 pi. But when it is jumped from higher energy to lower energy level, it will release energy which is equal to the energy gap between the energy levels, E2 minus E1. So when it is jumped from higher to lower, it will release a photon of frequency nu or of frequency lambda. Correct? So that. Clear? Then after that, so we have calculated the what is radius of nth orbit, velocity in nth orbit, acceleration in nth orbit, etc. This proportionality. Then energy in nth orbit also we discuss. And energy which is equal to energy in any nth orbit is equal to minus 13.6 into z square by n square. Minus 13.6 z square by n square. It is total energy. Total energy. So in that kinetic energy, total energy is equal to kinetic energy, but kinetic energy positive, total energy negative. But potential energy is twice the total energy, minus only twice the total energy, that we know. Next, so whenever energy jump from higher to lower energy level, how it is energy calculated, or energy of photon, which can be calculated by E is equal to z square into 1 by n1 square minus 1 by n2 square. Correct? So that is, after that, lambda we calculate 1 by lambda, wave number, frequency equation, maximum minimum wavelength of different spectral lines. So this finally, recoil energy and spectral lines and number of emission of spectral lines. Right? So tomorrow onwards, we'll discuss the doubts of your atoms. Okay? So MPC students, you can leave this session and join in your next session. And BPC student, you continue. So 5-minute break will take. After that, we'll come back to the doubts. Clear?